All right, here we are, SAT for week 14. We have one of those produce your own response kind of questions. We've got the number A is 110% greater than the number B. The number B is 90% less than 47. What's the value of A? So let's take a look at how we did on this question. You can see that there's only two spikes on this thing, where we have 63%. 80 of us said some number that's a little bit bigger than 9.8, which was the correct answer, by the way. And then it was this 28 of us, 22% of us said something a little bit bigger than 4.7. I think it was 5 point something, 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 something. Anyway, we said that this was a medium level to a little bit on the easy side kind of a question. So let's go ahead and dive into the solution. And when we do, I'm going to have to back this up and talk to you a little bit about some percentages and what it is that we do whenever we take the percent of a number and maybe add it or subtract it from the original value. So here's an example. Let's say we have sales tax. And that sales tax is an unreasonable 10%. Well, what does this mean? Well, it means if I have an item that costs, let's say, $50, well, they have to take 10% of that, and 10%, of course, means 10 out of 100, 10% out of 100, or per 100, which reduces to 1/10, which is, of course, 0.1. So I'm going to multiply this by 0.1. But whenever I do, this is not the final cost of my item, this $50 item. I have to add that back to the original price, the original $50. So what we have over here on the left side, this is the amount of tax. And then the 50, of course, is the original price. Right? And then we could go ahead and do our computation here. So 0.1 times 50, don't even need a calculator for that. All you got to do is move your decimal place over 1. So it's $5 of tax that you're going to add to your 50, and you get 55 bucks. Okay, now you may remember this thing called percent change, and percent change will allow us to figure out, let's say, if I have a final amount and I have a starting amount, that I can find the percent difference between those two things. I wonder what that percent difference is going to be. So if I take 55 and I subtract my 50, my original amount from that, so this is new minus the old, and then you divide it by the old, which is the 50, and then reduce this thing, you see you're going to get $5 out of 50, which reduces to 1/10. And what we just showed is that 55 is 10% greater than 50. Okay, now here's another way that we sometimes see this problem written, and that is this. Notice that they both have a common factor of 50, which means that you can pull this thing out. I'm going to pull this out algebraically. It is just distributive property backwards. And when I do, I'm going to get a 0.1. Oops, I get a 0.1 here plus, and then if I pull out a 50 from 50, I'm left with a 1. And whenever I simplify this, I get 50 times 1.1. Another way to interpret this is that you are taking 110% of 50. Okay, so that's going to come into play for, I'm going to say, the first part of this. The second part is when we're taking something away, some percentage away from a number. And this is like a discount. So let's say that you work for some place and you get yourself a discount that is 10%. That's not an uncommon discount. So we'll say that that's 10%. You're going to take that away from the cost of something. So we'll use the same exact example here. We'll say that you have an item which is $50, And you have a 10% discount. So, of course, you're going to multiply that by 0.10, as we talked about before. But this is just the amount of the discount. So it's the amount that you're taking away from your price. But I still have to take that away from the original cost of the item. Let me move this over because I got to subtract this from the original cost, which was the $50. And again, this one is original cost. And whenever I do my little computation, I of course got 50 minus, and then 10% or 0.1 times 50 is 5. And when I subtract, I have cost of $45. And then I can do the exact same thing that I did up here, which is a percent change, where you take your original 45 and you subtract, no, I said original, new minus the original over the original. And this time I'm going to get a negative 5 over 50, which reduces to a negative 1/10. In other words, we're discounting, we're going down by 10%. One way to interpret this, of course, is to say that 45 is 10% less than 50. Okay, and again, this is some common language that you're going to see right up here in our question for this week. Now, just like I talked about before, right up here, there's another way to look at this, and it looks like this, that I would do the little same exact factoring thing. They have a common factor of 50, so we would pull it out, and whenever I pull it out, 50 divided by this 50 is going to be the number 1, minus, and when I divide this guy by 50, I'm left with my 0.1. And whenever I simplify, I have 50 times 0.9, which is essentially 90% of 50. Okay, so I think that we have a better grasp of what it is that we're supposed to do in order to compute each one of these missing numbers, this A and this B. Let's see if I have enough little rubric over here in order to do it. Okay, so we're going to have to make ourselves some algebraic equations because we don't know what this A and this B is supposed to be. A is 110% greater than B. So this means, just like I did right over here, that I'm going to, let's say, take 110% of B, which is going to be 1.1. And again, that is because it is 110% is the same thing as 110 over 100, which is the same thing as 1.1. Okay, you're going to take that and multiply it times A. So this is very similar to what I just did here with the sales tax, but then you still have to add it to the original value of A. And by A, I actually mean B, right? It was 110% greater than B. Oops. And then plus, then you add it to the original amount of the B. And then you can go ahead and simplify this thing, and you get A is equal to, let's see, if I have 1.1 of something and I add one more to it, I get 2.1 of that B. Okay, so here's our first equation. But in order to find A, we need to figure out what B is. So they give us another little sentence here. It says B is 90% less than 47. So B is, and then I'm going to follow this same kind of idea down here. I would start with the original amount, and then I have to subtract the percentage away from that original amount. So my original amount is it was 47. It's 47 minus my 90% of that 47. So minus 0.9 of 47. Okay, and then I could simplify this just like I did right over here if you wanted to. Get this as, we could factor out a 47 for each one of these, 47. and this is going to be 1 minus 0.9 when we refactor it. So essentially, b is equal to 47 times 0.1. Well, we can do that without a calculator, because all it means to do is, when I multiply this by 0.1, I'm going to move the decimal place over one spot, which is 4.7. All right, so I've got what b is supposed to be equal to. Bam! And now, in order to find what a is, all I have to do is put it into the first equation that I came up with, which is 2.1 times 4.7. And on that one, I would probably rush to a calculator for. So, boom, 2.1 multiplied times 4.7, and I get 9.87, which was the correct answer, and it was the most common answer that you guys gave. So 9.87, bam. So 9.87 is 110% greater than 4.7, and 4.7 is 90% less than 47. The end.